Hello, welcome to another Thermodynamics 2 class videos. In this video, I'm going to explain activity 4 of lecture note 20. So here's the activity uh, as it is given in the lecture note. Let me share the screen. Share screen. All right, here's the activity. This is called adiabatic mixing. Adiabatic mixing means mixing without any heat transfer from the surrounding to the system or from the system to the surroundings. Two air streams are mixed steady and adiabatically. The first stream enters 35 degrees Celsius and 30% relative humidity at a rate of 15 cubic meters per minute, while the second stream enters 12 degrees Celsius and 90% relative humidity at a rate of 15 cubic meters per minute. Assuming that the mixing process occurs at a pressure of 100 kilopascal, determine the specific humidity, the relative humidity, the dry bulb temperature, and the volume flow rate of the mixture. So here is an example schematic diagram shown in here. So we have two streams come together and leaving out on this side. Let's draw a schematic on our notebook. Let's see, stop share and then sharing back again from my notebook. Let's see, open up a new page and now we are here. Now, let's look at how we're going to draw a similar type of diagram. So we have one flow comes in this side and the other flow comes in this side, and they both join in here and makes a single outlet flow. This is the inlet 1. This is says inlet 2. Let's say this is 1 and this is 2 according to the figure, and this is 3 out coming in here. All right. Now we have this, we can mark our control volume here. Right there. So the questions asked are to find the specific humidity at state 3. So we wanted to first find actually where the state 3 is located on a psychrometric chart. Then we can actually find the other details regarding that. So to locate it on the psychrometric chart, we need at least the temperature and relative humidity, some kind of properties required to find those things. But we don't have none of those properties except the properties at 1 and 2. But from the properties of 1 and 2, we will be able to find some properties of 3, and then we will be able to find the other properties from the psychrometric chart. Now let's see what things can we find for 1 and 2, or let's see how we're going to get to those answers. Specific humidity. Now how do we find specific humidity at 3? So specific humidity is related to the amount of moisture content and in the stream. So now we have discussed that the total mass flow rate is comprised of amount of dry air mass and amount of vapor mass. So if I say that m dot, let me take a black pen, m dot 1, that's the total mass flow rate of 1, which is equal to m dot a1, right, plus m dot b1. And then I can say m dot 2, mass flow rate 2, is equal to m dot a2 plus m dot v2, right? And I can also write m dot 3, that's the mass flow rate at 3, is equal to m dot A3 plus m dot V3. Now, I can write the mass balance for the total mass flow rate or individual components of mass flow rate. Now, in some systems, you should be able to, you can still add the mass flow rate, mass conservation. So assuming steady state, I can write for dry air mass, for dry air, for dry air mass flow rate, I can write m dot A1 plus m dot A2 equals m dot A3. This is my first equation. Okay. And then I can also write for wet or vapor, water vapor, m dot V1 plus it can actually change due to the evaporation or uh, uh, it can also change due to evaporation. So we don't know what the evaporation and those conditions are. Therefore, we leave that part for the time being. So assuming that there's no change in actually the water vapor mass, we can write m dot V1 plus m dot V2 equals m dot V3. Now, the equation for omega, that means specific humidity, is m dot V divided by m dot A. For we can write for any of these conditions, I can write m dot A1 omega 1 instead of V1, right? Instead of m dot V1, I can write by using this equation, I can write m dot V1 is equal to m dot A1 omega 1, m dot V2 is equal to m dot A2 omega 2, m dot V3 is equal to m dot A3 omega 3. Now we can write this total equation m dot A1 omega 1 plus m dot A2 omega 2 equals m dot A3 omega 3. Right? This is my second equation. And then also we can write the energy balance. No heat or work involved in it. So I can write m dot A1 H1 plus m dot A2 H2 equals m dot A3 H3. This is my third equation. So I can write those three basic equations. One is mass balance of dry air. This is mass balance of vapor. And this is the energy balance, or that's the first law of thermodynamics, basically, neglecting kinetic and potential energies. Now, if we find m dot 3, I can put, instead of m dot 3, I can put m dot A and m dot 2. And then I can find omega 3, and then I can find H3, right? So I'm going to solve for that. I'm going to use 1 into 2 m dot a1 omega 1 plus m dot a2 omega 2 equals m dot a1 plus m dot a2 omega 3, right? So omega 3 is equal to m dot a1 plus m dot a2, sorry, I missed something, m dot a1 plus omega 1 plus m dot a2 omega 2 divided by m dot a1 plus m dot a2, right? This is my fourth equation. And then I can use 1, 2, 3. From that I can find H3 is equal to the same equation, m dot a1 h1 plus m dot a2 h2 divided by m dot a1 plus m dot a3 2. Right? All I need is m dot a1, m dot a2, omega 1, omega 2 to find omega 3, and then m dot a1, m dot a2, h1, h2 to find h3. So if the first two equations are solved, first two questions are solved if I find m dot a1 and m dot a2 as well as omega 1 and omega 2. Now, our previous experience about the psychrometric chart tell us that you can find all of these things by using the psychrometric chart. Now, to find m dot a1, I can use to find m dot a1, I can use m dot a1 is equal to b dot 1 divided by v1. I can find that one. And then m dot a2 is equal to v dot 2 divided by v2. Now, v1 and v2 can also be found from the psychrometric chart, right? Now, by going to the psychrometric chart, I go to psychrometric chart, sharing the psychrometric chart. Add a pen. Okay. So here's we are on psychrometric chart. The first condition is at 35 and 35 degrees and 30 relative humidity. So 30, I take blue pen for that. 35 is here, and 30 relative humidity is here. So this is basically 30 and 30. So this is 1. And then number 2 is at 12 degrees Celsius and 90% relative humidity. So this is 20, 10, 1, 2, 12 here. 90% is this one. So this is my 2. This is 1 and 2. Okay. And then I can find, if I draw a straight horizontal line, I can find omega 2. Omega 2 is equal to 8, let's say using kilograms, 8 to the power 10 to the power negative 3, right? And I can also find omega 1. $11. So that's 11 times, let me erase that one. So that omega 1 is equal to 11 times 10 to the power negative 3 kilograms per, since this is in grams, I put it in kilograms. That's why I put 10 to the power negative 3. And then we also need V1. So V1 is 0.88 and this is 0.85. I would say 0.88 0.89. This is 0.89. So this is 0.88, or say 0.888 or something like that. So let's say V1 is equal to 0.888. All right, 0.888. And then V2, I can find V2. That's going to be, this is 0.82, this is 0.8, 0.81, 0.818, 0.818, right? 0.818, that is V2. And also we need H values. So for 2, H value, drawing parallel to that, this is 32. So let's take a parallel line from here. That's pretty close to 32. So we write 32, right? And then this line here draws parallel to this. Let's say 62, 63. 63, right? All right, so we have all the values we need. Let's take down those things into our paper. So we have 63.888 and 11. So if we go back, stop sharing, and then share our whiteboard. And what we have, let me take down it in blue for 1. So we have omega 1 is 11 times 10 to the power negative 3 kilograms of vapor per kilogram of dry air. And the H, we have 63 H1, 63 kilojoules kilogram of dry air. And V1, we have 0.888 cubic meters per kilogram of dry air, right? So those are the values we had. 11, 63, and 0.88. So if you show it again, if I show you again that these are the values, we had 63, 0.88, and 11. And then you have 32.818 and 8, right? 32.818 and 8. So I can go back to the whiteboard. I can write in red. Omega 1 is 8 times 10 to the power negative 3 kilogram dry air. H1 is 32 kilojoules kilogram dry air, and V2 is 0.818 cubic meters kilogram dry air. So these are the values that we found from that, and then all you need is to find MA1 and MA2 by using this equation, these two equations, and then you plug that into this here, MA1 and MA2, MA1 and then you have omega 1, omega 2, and then you can find omega 3. And then H3 can also be found in the same manner. So let's go into that. So first we find MA1, that is V1 dot divided by V1. So it is 15 cubic meters per minute. So I divided by 60 divided by 0.888. That will give us the value. So we have 15 divided by 60, and that is divided by 0.888. So you have 0.281. So we have 0.281 kilogram of dry air per second. Okay, and then we can find MA2, that is actually V2 divided by V2, that is 15 divided by 60. Again, the same volume flow rate, but different mass, 818. So it's 0.25 divided by 0.818 was 0.306 actually. So this is 0.306 kilogram of dry air divided by per second. Okay, so these are the MA dot actually, and this is dot as well. So the mass flow rates are found, and then we have an equation for omega 3. So you have omega 3 is equal to MA1 dot omega 1 plus MA2 dot omega 2, and then you have MA1 plus MA2. So we have 0.281 times omega 1. Omega 1 is let's see what the value for omega 1. Omega 1 is 11. So 11 times 10 to the power negative 3 plus MA2 is 0.306 times omega 2 is we found 8. Let's check again. Yeah, 8. Yeah, 8. That's 8. Times 10 to the negative 3, and then you have 0.281 plus 0.306, and you can find H3 in the similar manner. MA1 dot H1 plus M dot A2 H2 divided by MA dot 1 plus MA dot 2. So this is 0.281 times H1 is 63 plus 0.306 times H3 is 32. Yeah, these are the values, 32 and 63. This is going to be 0.281 plus 0.306. Now you can get those values. 0.281 times 11 plus 0.306 times 8 divided by 0.281 plus 0.306. It's 9.4544. Actually, it's 9.44 times 10 to the power negative 3 kilogram dry air. And then we have 0.2281 times 63 plus 0.306 times 32 divided by 0.281 times 0.306. 46.84. So we have 46.84 kilojoules kilogram of dry air. So those are the two answers for the first two questions. And then we go ahead and look at the other questions. This information, and dry bulb temperature and the volume flow rate of the mixture. So now to find the dry bulb temperature, we need to go back to the psychrometric chart. So stop sharing and share the psychrometric chart. Go to psychrometric chart here. Okay, so we found omega 1 and omega 2. So this is 9.44. So this is 8.5, 9.5. So it's close to 9.5. Let's take this green pen here. So let's say it's very close to 9.5. So I'm going to draw a straight line that goes across 9.5. Okay. And then also the enthalpy, we found enthalpy is equal to, stop share the whiteboard. Enthalpy is equal to 46.84. So 46.8, that's close to 47. So let's say 47, and then the other one is 9.5. 9.5, and then I'm going to stop sharing, share back this one. 47, so 9.4. So I just need a little bit more. 25. And then we have 40, 42, 44, 46, and 47 is right here. 47, I draw 47. Parallel line. And 196 right here. So that's our number 3. Number 3 in here. Number 3 in right here. So that relative humidity is, we can find the dry bulb temperature, which is equal to 23. So this is 23 dry bulb temperature, 23 Celsius, and then also the mass flow rate. To find the mass flow rate, we know what is the m.3 is, and then we can find the specific volume 0.84. This is 0.85. Let's say 0.852. So this is V3 is equal to 0.852. 0.852. And 0.852. Let's take back to our whiteboard. So we had this T3 is 23 degrees Celsius. That comes from the psychrometric chart. And we can find m dot A3 is equal to m dot A1 plus m dot A2. That is 0.281 plus 0.306. So this is 785.587 kilogram of kilogram dry air per second. And now we can find V3 is equal to m dot A3 times V3. So this is 0.7 times times 0.852. So you'll get 0.8587 times 0.852, 0.5. Right. So we get a solution is equal to 0.5. Okay, 0.5 cubic meters per, because this is in kilograms a second and this is in cubic meters a kilogram, so cubic meters a second. So if you need to multiply that by 60 times 60, you get 30 cubic meters per minute. That's it. So this is the solutions for this question. So just to recap everything, what we did initially was to write the mass conservation. So we know the total mass is equal to the mass of dry air plus mass of water vapor for each state. And then we found the dry air mass balance using this equation. And also we know that omega is equal to mv divided by ma by using that, because water vapor mass is also conserved. I can use this equation, mass balance for water vapor, right? Same equation. I just use these relationships over there. And then energy balance is omega W and Q equals 0. In this case, no work, no heat, only balance of H values when you disregard changes in potential and kinetic energies. And then from this equation 1 and 2 combining, I obtain this equation. And then also combining 1 and 3, obtain this equation, H3. Then all these values are found by using our psychrometric chart. You can see those blue and red lines refer to state 1 and 2. And then also we found, a specific volume as well to find the mass flow rate. Then just after finding the mass flow rate, we apply that equations and find omega 3 and H3. Once I find omega 3 and H3, I can go back to the psychrometric chart. As it is shown here, the green line and this green line, H is 47, and then this is 40, this is 9, and that intersect in here. And then that is our dry bulb temperature, 23, close to 23. And then we can find V, specific volume, 0.852. And those two values, from those two values, I can find the dry bulb temperature can be found, and then you can find the mass flow rate by adding m dot a1, uh, m dot a1, here m dot a1 and m dot a2, and then you can find total mass flow rate. Then you have V3 found from the psychrometric chart. This is from chart. This is from also chart. And then you can find V3. Okay. This is multiplied by 60, you get per minute. Okay, that's hope you understand the problem, and keep working on the other homework problems as well. So thank you for listening, and see you next time.